What should we do with the right side?
Make the denominators the same.
Yeah, let's make a common denominator. So how do we make a common denominator given these things? The common denominator will be the product of each of the denominators, meaning we'll multiply the top and bottom of the first by the denominator of 1, and we'll multiply the top and bottom of the second term by the denominator of the first term. Let me just make some more room here. So we have this on the numerator and a difference of squares in the denominator. And this denominator is common to both now. That's why we did it. And so we could evaluate our difference of squares and we can combine the numerators.
There's a 1 minus 1, so the 1 goes away?
Right, so we'll show the work of combining the numerators. So don't forget we have to subtract these two terms. So we're subtracting both of them. And we'll distribute the sign. So this would become negative and this would become positive. The negative 1 would cancel with the positive 1. And the cos double negative would become
2 cos theta.
Would become positive, so 2 cos theta over this stuff. And we could complete the difference of squares in the denominator now. Foiling this, we would get 1 minus cos squared theta after we reduce or simplify. Yep, so we could recognize this denominator now is the rearrangement of this identity.
Sine squared theta.
Good. You can see that the denominator of this would become sine squared theta. As we rearrange the identity, now what?
Is there another one?
Yeah, so let's see what happens when we rearrange the top identity for sine squared theta, squaring everything, where we would have sine squared theta equals the product of tan squared theta cos squared theta.
Oh, that's the new bottom one?
Yeah, we'll substitute for the bottom. So our cos will reduce. So let's substitute for the cos theta on the bottom. So we have 2 over tan squared theta. And substituting for cos theta, we can see here in this identity, would be
sine over tan?
Would be sine over tan. This cancels one of the...
So it's the same now?
Good. Therefore, the right side equals the left side.